Okay, so here's example 8.4b, and this is kind of a repeat of part A, as the name suggests, but done in a little bit simpler manner. We said previously, that the work done in any system, the net work, I should say, equals work 1 plus work 2 plus work 3, work 3, etc. Okay, but we have to, for all those, we have to find force times distance times angle, force times distance times angle, force times distance times angle. There is a simpler way of doing this, and this was on the previous slide in our notes as well, which I'll go back to in for just a second right here. The other way we can describe the net work on an object is simply the net force on an object times the distance that it travels times the cosine of the angle between them. All right, so we don't need to do all those individual works separately. Let's just find the net force, multiply it times the distance, and then the angle between them, and then we have our net work. So let's go ahead and do that. All right, I'm going to do that for example 8.4b. Now I'm going to write my draw my diagram here again. All right, so here's my car. It looks like a hat with wheels. Here's our angle right here, theta. Okay, so let's label all of our forces acting on it. We have mg, of course. We have the force parallel, right? We also have our force perpendicular. And we have a normal force directed upwards from the road. And we have, looks like I'm writing fair, but that is the force of air resistance acting against the movement of the car. All right? Well, the question is, what is the net force on the car? Okay, we said that the net work equals the net force times distance times the cosine of the angle between them. All right? Well, let's look at the net force in the perpendicular direction. What's going on right here? Is the n winning out? Is the force perpendicular winning out? Neither is winning out, right? Because in this case, the normal force is going to be exactly equal to that. So the net force in the perpendicular direction equals 0 anyway. So really, the net force on the whole car, and by the way, sometimes I write it F net, other times I write it sigma F, and it looks like a backwards 3 right there, but it's the same thing. All right. The net force in the car is really going to be the net force in the perpendicular, or in the parallel direction, right? Because there really is no movement in the perpendicular direction. So what is that? Well, that's going to be our force parallel. And what else is acting in the parallel direction but the force of air resistance? That's really our net force in the car. So the difference between those is really the net force moving down the hill. So we can say that the net work is going to be our net force, like we said up here. But that's going to be force parallel. Sorry, it's not in green. Looks like Fn. Minus the force of air resistance times the distance d, all right, times the angle between them. Okay. Now, the angle between them will determine if the net force is acting up the hill or down the hill right here. My guess is that the net force, this one's going to win out, and so the net force is going to be, let's make that, say, orange, all right? We'll say the net force, or the difference between them, is going to be directed down the hill. All right? But whatever direction the net force is, phi is going to be the angle between that net force and the distance d, which we said in the previous one. I think I marked it as blue right here. So that's our distance d marked down the hill. Phi is going to be our angle between them. All right. I'm going to go ahead and assume that this is going to win out, and the car actually is going to be moving down the hill because of this net force, and so therefore the angle between them is going to be 0, kind of like in the previous one. But this right here is a lot easier than adding up all those works separately and or multiplying the force times the distance separately, getting all those works and then adding them up. All right, all you have to do is find the net force, which is this right here, and then multiply d times the cosine of the angle between them. All right, makes things a little bit easier than in part A. Okay, well, thanks for watching, and I'll see you on the next one.